that you will see on some foods. And it provides an ability to compare products, to understand how one product stacks up against another, not only in terms of an overall single rating, but also in terms of various aspects of performance, so that the designer, the architect, can determine which aspects are most important for the particular project that they're working on. Now, in order to develop EPDs on that, products tend to be very different. And so the same rules that are used to develop EPD for concrete masonry assembly, for example, would be different than perhaps the rules that are used for evaluating a polystyrene or a fibrous glass insulation product. And the means of developing the rules that are used for developing EPD requires the manufacturers to come to an agreement and develop product category rules. These are the rules and requirements for developing EPDs of a certain product category, and they enable transparency and comparability between different EPDs on various products based on the same PCR. And the product category rules can then be harmonized for other products. And these are developed by interested parties such as manufacturing associations or standards development organizations, and it requires independent verification of review panels because, once again, these are issues that deal very directly to competitiveness for the interested parties, and also in the ability of getting complete disclosure for the users of these particular products themselves. Now, going back to what's a green building, to some very simple examples, we only need to look to our ancestors and indigenous cultures, and there are many examples of buildings which truly have been harmonized and work in terms of renewable resources, locally sourced materials, and designed for the local climate. But as we all know, as society has become more technologically advanced and population densities have increased, we've tended to drift away from this close association with nature. And still, though, we have the objective of building sustainable buildings. Now, this is a particular structure that I happened to come across in the city of Chicago that was put together by a fellow that, in actual fact, one could argue that this is sustainable from the standpoint of the LEED green rating system. It certainly is located near public access everywhere. 100% water savings, it uses no water. 100% energy savings, has a reflective roof and has no energy input, and 100% recycled content. But obviously, this is not the example of what we want to do, and one of the key aspects of this is that it does not meet code. And my purpose for this particular illustration is to point out that the green standards do not, and the green code does not stand alone any more than the building code stands alone. The green codes that are adopted, the energy codes, must be compatible with the building codes and the structural codes so that each of them work together and do not contradict or create problems in designing buildings that meet the performance requirements of the buildings. Now, what are those performance criteria? Well, traditionally, buildings must perform in many different ways. Obviously, key and most important, there's a particular purpose or function for which the project was developed and designed. We also want our buildings to be beautiful, to have an aesthetic appeal, and certainly the skyline of Dubai gives you a brilliant example of that being executed very well. There, of course, needs to be the safety and integrity aspects of structural integrity, life safety and fire, and complying with the codes, and last but certainly, one of them foremost, it has to meet the cost constraints of the project itself. Today's buildings, so, have the added complication that we have more stringent energy requirements. We're now becoming aware of the fact that with moisture durability issues, durability is a more difficult aspect and sensitive aspect that must be taken into consideration. Indoor environmental quality as it affects the comfort and the health of the occupants, and sustainability. These all add layers of complexities to design and construction of the building. Now, one of the ways we ensure this is through the implementation of building codes. And these are simply the regulatory requirements pertaining to the design and construction of buildings. A building code is established law adopted by the particular authority having jurisdiction, which may be a community, it may be the state, but it establishes the rules for what buildings can be built, where those buildings can be built. It impacts the design of the buildings, the materials that can be used, the construction methods that are used in them. Building codes, by their very nature, must be minimum requirements to protect the basic aspects of health, safety, general welfare, and affordability. Again, all of these things involve certain trade-offs, and the development of a good building code involves a risk assessment scheme to try to strike the ideal balance for the benefit of the owners, the occupants, and the community as a whole. There's no simple way that you can answer everything at once. In that context, that building codes address the minimum requirements for performance, you could also say that a building that meets codes, the worst is actually the worst building that you can legally construct. And that is an important consideration when one looks at sustainability and energy performance, because buildings are complicated networks of interacting systems, and high-performing buildings are even less forgiving. Just as a high-performance automobile operating at the envelope of its performance is less forgiving of errors and mistakes in its operation, so are these buildings. They perform marvelously, they do things that once would not have been thought possible, but at the same time, the interaction of the systems are such that if one element does not take into consideration how it impacts another element of the building, there can be problems that come forward from that. So building codes do not look, as a rule, at how each system impacts every other system. And the designer of such building needs to bear in mind that simply meeting code may not be good enough for a building to meet the goals of sustainability and green construction. Codes define the basic conditions of acceptance, but they set a level which may not be sufficient in all particular applications. Codes drive innovation, but they also tend to resist change. They tend to be conservative, as they must be in their risk assessment role. And codes rely on standards really to fill in many of the gaps and many of the details which they cannot cover in all possible areas. Building material standards define our materials by telling what they are and what they are not, and in this respect, they are prescriptive in nature. They can also be performance in nature in terms of addressing how those materials must perform and specifying how they must be tested to ascertain that performance level. Standards serve a function for all of the industry, the designers as well as the manufacturers, by leveling the playing field. They provide the metrics by which quality and performance can be judged, and what's not included in the standard can sometimes be as important as what is included in the standard, and that is the reason why it's important to rely upon consensus standards developed by technical experts from all different aspects, both the producers as well as the users and the designers, in order to make sure that the standards themselves are complete and satisfactory for the designers to be able to make informed choices in selection of materials. Another aspect about standards used in building codes is it's important to look for mandatory versus permissive language. This is something that was brought home to us in the American code system when the model codes became very engaged with ASTM, ASHRAE, and many of the other standards developing organizations a little bit over 20 years ago, to realize that mandatory language, which very specifically states what you must have, is something which provides a measurable output. If you use permissive language, such as should, this becomes an ambiguity which allows room for interpretation and oftentimes for misuse or of the particular standard or product. Standards convert proprietary products also into commodities. So in that regards, oftentimes you'll find manufacturers will have aspects of their products that they don't want to include in standards. Again, a consensus standard process, which involves not only the manufacturers but also the users and the designers, is the best way to ensure that the standards that are produced actually cover all of the properties and performance aspects that are important. Standards become mandatory when they are cited by the building code. And once it becomes part of the building code, it becomes part of the regulatory structure, and materials must comply with what's in the standards. In that regard, building codes very much drive market changes. If a standard is not cited by the code, well, then its use becomes voluntary. But there are still many standards which are very important to industry and are required, even and are not used directly by the codes, but are still used by the industry. Building codes, basically, to summarize, building codes establish what materials can and cannot be used. Building codes create strong market-driven incentives and disincentives for innovation. So in that regard, it's very desirable, in fact, it's necessary to have codes which are flexible and allow for performance-based provisions for new materials to be permitted to be developed and brought in developing areas such as sustainability and green construction. Opportunities and risks exist for both the designers, the architects, and the manufacturers in the areas where the codes are silenced. The role that standards plays is to establish how products are to be compared. And likewise, good standards must be meaningful and they must be measurable. So new codes and standards will continue to be needed and to be developed in the future. They provide, among other things, a means of providing an established common language for defining terms to end greenwashing. The standards alone, new standards, are not sufficient. It is necessary for them to be implemented in the building codes because it is the building codes that really drive industry adoption. These are what motivate, for example, manufacturers to do innovative new work on product development as the codes require changes in performance. That said, I'd like to talk a little bit about one consensus standards organization with which I'm most familiar, ASTM International, and some of the work that it does in sustainability. ASTM is a private sector organization. It was established a little over 100 years ago. It develops voluntary consensus standards in a total of more than 90 industry sectors. It is not a government-funded agency. It receives no government monies. Its business model is based upon surviving by means of the revenues that it raises from the sales of its publications and also other related services such as some certification and services and training services. Its headquarters are just outside of Philadelphia, Pennsylvania, in the United States. It also maintains offices in Beijing, Brussels, Mexico City, and Ottawa. ASTM is an international standards development organization. It complies with the World Trade Organization's 6 principles for the development of international standards as set out in Annex 4 of the WTO's Technical Barriers to Trade Agreement. It is open to stakeholders regardless of their nationality and borders. It enables public and private sector cooperation across the globe. It uses electronic tools so that people can participate in the development and the delivery of standards worldwide. And its standards are used globally for trade, research and development, product testing, regulation, and quality systems. And also its leadership in its board of directors is multinational in character, with directors that have come from Canada, France, Netherlands, Saudi Arabia, and South Korea, just to name some. As I mentioned, ASTM does comply with the World Trade Organization International Standards Development Principles. These are listed here, and if you go through the participation of ASTM or any other standards development organization, then you will find that they should be in alignment with all 6 of these principles in every mode. Our ASTM standards are responsive and are relevant to the global marketplace. Interestingly enough, over 50% of ASTM standards are distributed outside the United States, and over 6,300 ASTM standards are the criteria are cited as the basis of national standards in a total of 75 countries outside of the USA. ASTM today consists of 143 technical committees, of which the 30,000 members maintain over 12,000 active standards. A quarter of those members come from 135 countries outside of the United States. And as I mentioned before, there are over 6,300 citations of ASTM standards in national regulations outside of the US. I think it would be helpful to describe the ASTM balloting process, which is not different from what you'll find with many of the consensus group. Basically, the technical experts identify the need for a new standard or revision to an existing standard. And in response to that, the technical committee will form a task group. Now, the task group is charged with the basic task of developing the new draft or developing the revisions to the existing standards. The task group is also responsible to bring in the best technical expertise relevant to the particular project at hand. So you do not need to be an ASTM member to participate in the task group. Once they have produced their draft document, this has to go through subcommittee balloting and then main committee balloting. And if it fails to pass at either of those levels, then it goes back to the task group to resolve whatever issues were raised in the balloting process. Once main committee approval has been achieved, then the draft goes through society review where any ASTM member has an opportunity to comment on the standard. And if that is resolved, if there are no comments or the comments are all, once they are all resolved, then the Committee of Standards, one of the standing committees for ASTM, has the final task of reviewing the entire process to make sure that it has followed the rules and regulations of the ASTM bylaws and regulations, and then the standard is published. Voluntary standards, as I mentioned before, can be mandatory. They become mandatory when cited in a contractual agreement or when they are referenced and mandated by a government body such as cited in a building code. Mandatory versus permissive language is a very important aspect in these standards, and again, permissive language creates ambiguities which are open to interpretation, and that in turn creates areas where products that are said to meet the same standard may not in actual fact perform in the same way in all respects. Over 1,700 citations of ASTM standards can be found in the codes developed by numerous standards development organizations. Standards provide a practical and convenient way of establishing metrics. They incorporate the best knowledge and expertise in technology in terms of bringing in the experts who are most knowledgeable in the particular area. They facilitate updating and enable adoption easily, and they support the codes in many respects. ASTM many of their technical committee are developing standards which address sustainability in the infrastructure and the built environment. This is a partial list of those. I've bold-faced, I've highlighted Technical Committee E6 on performance of buildings because they are currently working on developing standards on building commissioning, and Committee E60 on sustainability, which I will tell you a little bit more about briefly. I would like you to be aware of the fact that their ASTM E60 maintains a sustainability database, which is basically a list of standards relevant to sustainability. This is accessible on the website. There are over 500 ASTM standards currently, and over 300 standards from other organizations. You're invited to visit this site. It's an excellent resource for finding out what standards refer to what aspect of sustainability. There's no charge for use, and in fact, if there are standards which you're aware of that are not included on their list, E60 invites you to bring that to their attention, and it will be added to the list. There is also a ASTM standard for sustainability in buildings, which is a collection of 202 ASTM standards that deals specifically with sustainability relative to buildings. Now, Committee E60 on sustainability deals with a number of general areas of sustainability, And specifically, it has committees that address construction, manufacturing, and meetings. Subcommittee EO1 on buildings and construction has 16 published standards and currently is working on 15 work items. Two of the key documents that it has produced are E2432, the Standard Guide for General Principles of Sustainability Relative to Buildings, and then ASTM E2114, Terminology for Sustainability Relative to Performance of Buildings. And I'd like to just discuss with you a couple of the aspects of where E2432 has had an impact on the sustainability or green building construction. One aspect of it is it calls to attention the need to look at the design of the building. In this particular example, the building owner decided that he wanted to take a more rigorous look at making his product or his building more green. And the construction had already begun on the structure, but among other things that they came across when they reviewed the design, it was observed that for 36 floors with 45 columns per floor, a circular column could support the same load using considerably less reinforcing steel and material that went into that. And so during the construction process, the columns were switched over to the circular configuration. There was a $500,000 savings that accrued to the owner, but more than that, there was a number of impacts in terms of materials saved and the corresponding impact on other environmental aspects of those materials. In the same review, along the same line, the building had been designed to use some massive steel girders to support some 30-story tall column, and it was determined that this could be by means of designing some shear walls that were constructed on site with concrete and reinforcing. It was possible to support the columns without having to bring in those girders. Not only were there savings and cost savings for the structure itself, but also for the urban community around that, being able to eliminate the need to bringing in those large girders considerably helped the community in terms of avoiding traffic backups and tie-ups. The standard also, 2432, looks at operating costs, and one of the major costs for a bridge such as this has to do with the annual inspections that are required for it. And it was determined that they would pressurize the arch rib chambers between it, which made it possible through a simple process to measure any loss of pressure in that. And that in turn provided them with a very simple means of simplifying the annual inspection. Basically, 10 days of congestion during which the inspection process underwent were avoided in this way, and the community was positively impacted. In the same project, it was observed that periodically in inspection, the hangers used for the suspension bridge need to be replaced. It was determined by putting in double hangers into the system so that each single hanger could support the load of the bridge. It was possible to build in maintenance provisions so that hangers, when it came time for them to be replaced, did not require the shutdown and the shoring that would have been otherwise required. This was a $180,000 increase in cost on a $16 million project, so roughly a 1% change in the cost, which had very substantial impacts on the community over the lifetime of that structure. Other aspects of it deal with using land efficiently and look at opportunities to use multi-use or multi-component operations in it. In closing, I'd just like to re-emphasize that green buildings themselves are very high-performance structures, and as such, the building codes must provide design flexibility for such complex buildings. In that regard, the green codes must overlay and complement the building codes, and as they are developed, they must be developed with the codes themselves in mind. Standards provide the metrics